Alright guys, so I wanted to make sure everybody understood the homework, so I'm going to go ahead and work it out so you can check your work, or if you're still confused you can just go through it. Alright, so here we go. Number 1, find the area under sine x plus 4. I'll just do from 0 to 6. Okay? So find the area under f of x equals sine x plus 4 from 0 to 6. Whipping out your graphing calculator will help here. So I'm going to go ahead and do that. Even though you should know that we should know what this looks like, but it's fine to use your graphing calculator, no problem at all. Clear, clear. We need to get out of parametric mode. Alright, go back into function mode. Alright, y equals. Alright, so we're going to type in, and we need to make sure we're in radians. Okay, so mode radians is selected, so that's great. Alright, so y equals. Alright, sine x plus 4. Make sure you close your parentheses right there. Hit graph. My graph looks funny, so I'm going to hit a zoom 6. Okay, zoom standard 6. So there we go. Now, notice I only need from 0 to 6, so I'm going to go window, x min 0, x max 6, and I think I can maybe restrict my height of the graph to probably 8. We'll try 8, and there you go. You got a pretty nice sine wave right there. Alright, so this is all we need to sketch basically. Alright, so and I guess I could restrict, I can make it look better by maybe doing the y min at 2. So window y min 2. They got a better curve going there now. So I'm going to go from 0, 1, 2, 3, 4, 5. Okay, then it's sine x plus 4, so it starts at 4 and then it oscillates. It doesn't have to be perfect, y'all. I know that's not how it looks. I ended my curve way too much. It basically makes an entire revolution here. So an entire revolution. Let me. There we go. That looks much better. Kind of matches the graph there. It makes an entire revolution. So there's 6, 3, 4, 5 in there somewhere. 1, 2 in there somewhere. Sorry, that's a little bit stuck together. So that goes off. We're finding this area under the curve. Remember, the integral only finds the area under the curve. Alright? So what we're going to do is we're going to do a definite integral. This is the tool. For the area under the curve. We're going to do from 0 to 6. I'm going to do that. Integral of sine x is negative cosine x. Integral of 4 is 4x plus c. Now I evaluate. Okay. Negative cosine 6 plus 4 times 6. Plug in the top, plug in the bottom. Remember that, we remember f of b minus f of a for that. f of b minus f of a. Alright, so, and then minus, so we gotta have Kansas in there. And then, so 0, negative cosine 0, plus 4 times 0. Alright, so that's x nay. Negative cosine 0 is negative 1. So that's all that's left of that. And I don't know what that is, so I'm going to have to take out my calculator. Show me what that is. Cosine 6 radians. 0.960. Dot dot dot. Plus 24. Okay. So there I go. 0.960 plus 24. So I'm going to use my calculator here. Plus 24. Bam. And then minus negative 1, which is really plus 1. So plus 1. Bam. 25.960 units squared. There we go. That's number 1. All right, number 2. And let y'all get a last look. You pause it if you need to. All right, number 2. Find the area enclosed by 9 and 2 to the x power from x equals 1 to x equals 3. So here's number 2. Enclosed can also be used, the word bounded by f of x equals 9 and g of x equals, let me make sure that's right. Yep, 2 to the x power. So I need to make a graph. Try not to run off the page. Now I know what this looks like. It's a vertical, it's a horizontal line. 2, 3, 4, 5, 6, 7, 8, 9. It's a horizontal line at 9. So there's f of x. And g of x, well, I know plug in 0, I get 1. Plug in 1, I get 2. 2, I get 4. Plug in 2, I get 4. Well, that's not exactly right. 4 right there. And plug in 3, I get 8. So it goes like that. G of x right there. Okay. So here's 1 to 3. A, B, that's 1 to 3. So I'm finding this area. I want to find that area right there. Okay, the darkened in area. So what I'm going to do is I'm going to use my top minus bottom rule. Okay, integral from a to b, and it's going to be f of x on top minus g of x on the bottom dx. So integral from 1 to 3 f of x, which is 9 minus 2 to the x power dx. So now I can integrate this 1 to 3. It is 9x minus natural log, wait, I almost got that backwards, 1 over natural log 2 times 2 to the x power. It's not a chain, it's not a U substitution or anything, okay? It's just a simple exponential tool plus c. 1 to 3. Alright, so 9 times 3 minus 1 over natural log 2, 2 to the third power, Kansas. put it down. No, I'll put it here. 9 times 1 minus 1 over natural log 2. 2 to the first power. Okay, so that's 27 minus 8 over natural log 2. Okay, and that's minus 9 plus 2 over natural log 2. Now these 2's can't cancel, and this 8 and this 2 cannot simplify. Okay, let's zoom in here real quick. Okay, now here's something pretty cool. Combine, you get 18, and that becomes 2 minus 8 is minus 6 over natural log 2. And I can actually write that as my answer, units squared. That's my answer. Okay? I don't need a decimal. Don't need decimals if not necessary. Okay? And that's number 2. And let's go ahead and move on to number 3. Alright, number 3 here, I'll just work it out on the paper. Alright, find the area enclosed by f of x equals 4. 1, 2, 3, 4. And g of x equals x minus 4 squared. 1, 2, 3, 4. And a parabola. Okay. There's g of x. I need to find this area. Okay. Now, alright, so I know that this is the top minus bottom. Okay. And so I'm going to do the integral from a to b of the top f of x minus the bottom g of x, because I need to subtract out all this squiggly area. Right? This is the f of x area. It's a big old block. I need to subtract out the area under g of x to get this area right here. Alright, so integral from, well, here's the problem. I don't know a and b. I know f of x is 4 and g of x is minus x minus 4 squared dx. So I need to find out where they intersect. Well, I know they intersect at the solution of f of x equals g of x. So I set f of x 4 equal to g of x, x minus 4 squared. Now there's 2 ways to solve this. Okay. Well, there's actually a couple. I can get rid of this square here by square rooting plus and minus 2 equals x minus 4. So in this case, x minus 4 equals 2 plus 4 x equals 6, or x minus 4 equals negative 2 plus 4 x equals 2. So you got to do both here because of the plus and minus. So there's one way to skin a cat. The other way would be is if I FOIL that out. 4 equals x minus 4 squared. FOIL it. 4 equals x squared minus 8x plus 16 minus 4 set it equal to 0 equals x squared minus 8x plus 12. Okay, almost running out. Alright, then I factor. Alright, this factors into x minus 6, x minus 2. So I solve x equals 6, x equals 2. You set both of those equal to 0. You set your x minus 6 equal to 0. You add 6, x equals 6. And likewise for 2. Alright? So I know my integral. Okay? I know my integral. And I need to get another sheet of paper. I know now I know my a and b. So let's take this, move it on down. Okay, integral from a to, not a to b, I know it now. It's the integral from 2 to 6, 4 minus x minus 4 squared dx. Now I can't integrate that, because it's a function inside of a function. Let me just move that up. It's a function inside of a function. Just FOIL it out. 2 to 6, sorry about the light there. Alright. 4 minus x squared minus 8x plus 16. Distribute the negative. 4 minus x squared plus 8x minus 16. Combine. So 4 and negative 16 make negative 12, so negative x squared plus 8x minus 12. And now I'm ready to integrate. Okay? Bar 2, 6, negative 1/3 x cubed plus 8 over 2 x squared minus 12x plus c. And I'll let you finish, because I'm about out of time. Alright, so that's it for your homework. If you couldn't do it, hopefully this helped, and I'll see y'all tomorrow.